Good afternoon. A very warm welcome at this second webinar of the WaterSolutions series that is part of the Amsterdam International Water Week. In this series, we take a deep dive into the 4 sub-themes that will all lead to the Amsterdam International Water Week taking place in the beginning of November this year. And together with scientists, innovators and experts from cities, utilities, the industry and agri-food, we bring new perspectives and insights to the table. For the second webinar, the main question is how do we realize, reuse, recycle and recover in practice? So for the next 75 minutes, you can expect some good practices on water efficiency and wastewater reuse, and we will exchange ideas on how we need to govern, finance and legislate this transition we are in. Taking a short look at the first webinar that took place last month, we focused on clean water and ecosystem restorations, and we heard the perspectives of the European Union on this topic. And we also had some inspiring and ambitious projects for aiming at swimmable and drinkable rivers. And taking this, that last seminar one step further, we will today focus on the water quality from a reuse, recycle and recover perspective. And as I said, this all leads to the Amsterdam International Water Week taking place in this November, that has as its main theme, Blue-Green Deals with Integrated Solutions. You see the series of 4 that we're aiming at, and today reuse, recycle and recover is our main theme. Then we have some practical information. We are very happy with the amount of attendees from over 70 countries worldwide. So once more, a very warm welcome to all of you. We saw USA, quite a few attendees from the USA, France, Portugal, Iran, China, just to name a few countries. So very warm welcome once again. On a practical note, please switch off your camera and your microphone. The webinar is being recorded, and please use the hashtag if you're on social media. I'd like to share some of the insights that are being covered today. And of course, we're looking for as much interaction as possible. We have quite a few panelists and limited time as always on webinars, but we have some moments in our webinar where we specifically look for questions via the chat. So please use the chat function if you would like to participate in the seminar. I'll get the questions via my mobile phone. So if I'm looking at my phone, it's not because I'm not interested in the webinar, but because inspiring questions come along. So thanks Nupur, my colleague, for sending me those questions. And of course, the panelists that I'll introduce shortly might also respond in the chat function directly. So there's various ways of coming back to your questions. Taking a short peek at the program outline for this afternoon. We'll start with Mark van Loosdrecht. He's from the Delft University of Technology. He will give an introduction of the sub-theme of today and the different focus areas of reuse, recycle and recover. Then we take a look at the industrial perspective coming from Heineken. Jan-Willem Vosmeer is with us, and Zero Brine, Dimitris Xavienos is with us. And the agriculture perspective from the Dutch Ministry of Agriculture, Nature and Food, and from the top sector Agri and Food, Willemien van Asselt. Then we take a look at the risks of reusing wastewater for health, focusing on agriculture and industry. And then we have Nienke Hofstra from the Wageningen University in the Netherlands with us. And before we Before we go to the discussion, Hans Stielstra will cover the perspective of the European Commission on this topic. So a very warm welcome to our panelists as well, of course, and then I'd like to introduce Mark van Loosdrecht with a little bit more words. Mark will share his knowledge on converting waste into products, focusing on well thought out business cases. That's a specific angle. Of course, there's much more to tell, but I'll leave that to Mark van Loosdrecht himself. So Mark, please, the floor is yours for your presentation.
Thank you, Bart. I will try to give a brief presentation with some ideas and my observations around water reuse and recycle and recovery. And maybe I can get the first slide. Yeah. So I will mainly focus on resource recovery from wastewater. That's my field. I can, in the discussion and in the question and answer session, try to comment on much more aspects. But the wastewater is the focus, and municipal wastewater in my case, because municipal wastewater is very general, and industrial wastewater, I have my opinions there, but that's each time depending on the local situation. Can I have the next slide? If we talk about reuse and recycle, and we talk about municipal wastewater, we talk essentially about a few different categories of reuse and recycle. And the first one of that is water. That's of course the most obvious one. And in general, for water, we could say that technology is there, it can be used, it's even not that expensive compared to drinking water production as such. But the use and the policies around it will very much depend on local water demand. So how much shortage is there in the drinking water supply? Is there agriculture around it? Is there industrial users which might benefit from clean water? And also reuse in nature restoration, etc. might have. The reuse and recycling for water is actually, in my view, quite well there. It is integrated in the primary processes of water utilities, but whether it's useful and how useful it is will always depend on the local water situation, and it's not a kind of one size fits all. The next slide. So energy is probably the most discussed after water, but that seemed obviously as obvious. Energy is the most discussed one for recovering of materials at a wastewater treatment plant. And here we have to conclude that the wastewater treatment plants very often can still save significant amounts of energy. And before we start to recycle and recover, it's maybe also good to have a good practice of saving and optimize the energy at the treatment plant, and choosing in treatment plants with lower energy consumption than maybe the conventional ones. Also, from the operation point of view, it would be much more interesting to be energy autarkic, meaning don't have any contract with an energy supplier. Make sure that the biogas you produce, but maybe also solar cells, wind energy, make the plant autarkic, because that would be a significant cost saving. Whereas the energy itself, it is relatively low in value. So it is important, but it will hardly drive the cost. It's the line towards the electricity supplier, which is the really expensive part. And if we talk about energy reuse, the attention is very often going to reuse of biogas, but looking at wastewater treatment plants, it's the heat in the effluent, which contains effectively much more energy than the COD in the wastewater itself. So attention for effluent heat usage could be increased if we want to be more circular. Next slide. Then nutrients. Nutrients are, of course, also a heavily discussed one and also implemented at certain places. Here the point is on a large site that the amount of nutrients in a wastewater treatment plant is quite significant, you could say, but on the total nutrient market, it's very limited. So there's a very difficult to bring the nutrients back, because the market in the total nutrient market, it's small. The other part is that until now, the nutrients have got attention, but very often in the first option, and that's in this very often struvite recovery. Whereas if you look to other minerals which could be recovered, like vivianite, it might be way more efficient, because with struvite you generally recover about 10 or 15% of the phosphate at the treatment plant. Vivianite allows maybe 60 to 80% recovery. Many utilities implement currently phosphate recovery, mainly driven by savings in maintenance cost or savings in sludge handling costs. So with internal drivers, still no external drivers to really go to a cycling of nutrients. Next slide. So in chemicals, there's a range of developments. Partly that's recovery of cellulose, which is toilet paper, which is discharged at about 10 kilograms per person per year. That's a significant fraction of the total COD load. Easy to recover, but like for the nutrients, there's a very large cellulose market, and you come with very small amounts. Other aspects where there are developments, especially in the Netherlands, that's on the one hand making bioplastics in the form of PHA out of wastewater, feasible, and developing into demonstration plants. And there's an option to recover the EPS matrix from especially Nereda granular sludge, or even from flocculant sludge. From granular sludge, it's called Camera. And that has nice gelling properties, but also good binding properties. And here, yet the driving forces would be savings again in sludge handling, but also the potential of a commercial product. And the interesting thing with Camira, that already 2 loads of Camira have been shifted just on a commercial contract without direct subsidy on it. And this value of the product could potentially drive the recovery itself instead of many other cases where the value of the product will not be sufficient to drive the recovery. And next slide. So one of the major problems is there's a lot of technology that's developing. There's still very much space for developing new technology for recovery, new products to recover. So that's not the end there of creativity. But the real bottleneck is that if you want to recover certainly chemicals which have value, to get that value out of these chemicals. And that is needs a system change. So there where in the industry, in the production industry, usually there's one big mine that supplies all the raw resources, and then the centralized production facility to produce products which are then distributed to consumers. Well, actually that whole value chain is generally a private operation and is well organized. If you come with material from a wastewater treatment plant like Camira, the problem is there could potentially be already 300 sites in the Netherlands. So it's not one big mine, it's a lot of very small suppliers. So you need to organize that, to collect that raw material, to make it into a defined raw material, then have a production and consumer products from the normal value chain. But the other system of change which will be needed is that now the supplier is likely a public authority and not a private company, which gives all kind of public-private interactions, which are not that well defined once you start to come into the details. And as usually the devil is in the details when you want to develop this kind of value change. Next slide. So summarizing, overlooking to reuse, recover from municipal wastewater, but for a large part also from industrial wastewater and somehow from drinking water production. Water recovery when needed, it's occurring, it's possible. There's not too much issues there, although there's always some legislation and policy. Energy, in my view, main thing is save as much as energy possible by doing your operation in a wise way and give more attention to effluent heat instead of to biogas. Nutrients is kind of nice to have. It is important to do it, but until now there's not a really strong market driver. EPS and potentially other chemicals have the potential to be economically so strong that they can drive their own production at the treatment plant. But what's essentially needed is more attention for the value chain and logistics of recovered material out of treatment plants in order to make really reuse and recovery a viable option. And then with the last slide, I just want to put you to some of literature which has recently been published by our group, where we also in more general context try to look into the design of water resource recovery factories. Thank you for the attention.
Thanks a lot, Mark. Yes, there I am again. Thanks a lot, Mark, for your concise presentation. I'd like to start right away with a question from Jeroen Tielman. It refers to the energy slide where you said how you talked about COD and how do you convert it into energy. That's basically his question. How does COD represent energy and how can you convert COD into energy?
Yeah, so COD is effectively a measure for the amount of organic matter, and it measures how much oxygen you need to burn all the organic matter. So it's essentially the amount of oxygen you need for burning is also the amount of energy you can get out of it, like in a normal plant. Of course, it's in the end a bit different, but the basic principle is the same. And you can recover it by converting the organic carbon, the COD, into methane. And then methane is like gas. You can use that for power generation.
Okay, thanks a lot. Can you talked about some successful examples already, Camira, for instance. What was the main challenge to face and to tackle when you cover that that specific well, subject or project?
Yeah, so the main challenge to face is what I showed in that last slide. It's developing a value chain. That's the same for phosphate recovery. Once you recover something at a treatment plant, it's a small volume. If you want to make that into products, you need to scale up. You need to create market volume, and that is not there, and that has to be developed in some ways. So there are some applications that are small applications, but some of the if you in the end want to make this really viable, you need to gather camera from several treatment plants. Now, it will not work if all the treatment plants in the Netherlands start to compete with each other to sell their camera, because then the price will become so low that you don't get any value. At the same time, if public authorities like water boards team up together to pool all their camera together and try to bring it to the market, it will be seen as a kind of cartel. And that is also not allowed. So there is, you need to find a way that you can create market volume, that you can get a fair price, and at the same time prevent things like cartel formation, etc. And that is not solved. And there's where a major part is. And the other part, which is solved in the meantime, was when we started with it, we got a lot of interest from industry. But the industry immediately asked, give us a few hundred kilograms to try it out in our machines. But if you do this in the lab and in the first sets, and you just produce a few grams of maybe 1 kilogram in a week, you have to scale that up. And that costs a few million euros to build the installations. Now, luckily, since a year, these installations are there. So now we can provide significant amounts of, if someone wants 100 kilograms of camera, we can provide it at a reasonable cost. So that is now since a year overcome, and that was another major hurdle.
Okay, thanks a lot, Mark. We will cover this in more detail at the discussion at the end, where you will also reflect on all the things that will have been said then. And now I'd like to introduce the industry perspective. If we look at implementing these resource recovery value chains that Mark has already introduced, I'd like to give the floor to Jan-Willem Vosmeer. He's Sustainability Officer at Heineken. Hi, Jan-Willem, welcome. I think you have to unmute.
Oh, I'm sorry. Good afternoon.
Hi, Willem. No problem there. Yes, just wondering, because we've read recently that there's a new sustainability strategy of Heineken, and could you reflect on that? Could you highlight the main topics of that strategy, please? Sure,
happy to do that. And maybe you can show the first slide, because it will tell the story. Yes, great. So yes, we indeed last week we launched our new 2030 strategy. Actually, we tried to develop a strategy that is so simple that you can actually summarize it on the back of a coaster, which you see here. You could say this is our navigator, and you see three main pillars: an environmental pillar that defines our path to zero impact, a social pillar, which is our path to an inclusive, fair, and equitable company and world, and one responsible pillar, which is so linked to our industry, which forms the path to moderation and no harmful use. I will not go into all the details and of course zoom in on the environmental pillar, but it's good to know that each pillar has 3 ambition areas. So there are 9 in total, and each ambition area has 1 or more concrete commitments and targets. We have 22 in total, and you see the iconic green circle on the footprint is actually the real footprint of our Heineken bottle, Heineken brand bottle, and it reminds us every day to leave our mark by limiting our potential negative impacts and maximizing our positive contribution. And it also reminds us, in a bit of a playful way, of our planet, our path towards a circular business, and our journey, which is always an imperfect journey towards a better world. But let's zoom in on the environmental part and specifically. Yeah,
the water agenda. I'm really looking forward to that. Yes, thanks.
Exactly. So that's the next slide. I only have 2 slides, so that's very simple. And here you see our water agenda, which is one of the 9 ambition areas. That's where we want to work towards healthy watersheds. And you see that we look at it from a very holistic point of view. And really front and center is to support healthy watersheds, especially for breweries that are located in water-stressed areas. And out of the 170 breweries around the world, we have 30 right now being identified as being located in a water-stressed area. You see that little triangle, the water triangle in the upper right corner, is actually the three elements on which we push the buttons and turn on the buttons for these breweries, and they need to work on all three. It's not either one or two, it's on all three. So if you look at efficiency, which is of course normally something you have first in mind, is of course you want to be as efficient as possible. So you need to continuously increase your efficiency, because it's always best to not use water. I still remember we started at 5 liters per liter on average. We are now on average in water stress areas close to 3.1, and actually for 2030 we want to go to 2.6 liter water for a liter beer in water stress areas. But that's not enough. If you only would focus on efficiency, it will not sufficiently support a watershed, and you will not come to a positive impact. So the other thing is that we want to have those breweries maximize their circularity, and also to have, and that's for all breweries worldwide, because that's the basis you need to have in order, is that 100% of your wastewater is being treated. And we sometimes forget that, but actually I think around 80% of human wastewater is not being treated around the world. So that's a basic element you need to have in order. But if you have that in order, you can start using the maximizing circularity, and I will come to that a little bit more specific. The third element is water stewardship, and that's really where you look beyond the fence of the breweries, where we want to 100% balance and even more bring back the water that is being taken out by our breweries, because most of the water is brought back, but of course the water you consume for your bottle of Heineken, and that also leaves the local water cycle through evaporation and your byproducts, that is what we want to give back and return through replenishment projects like restoring watersheds or reforestation. The image you see on the bottom is the Doñana wetlands in Spain, where we have a few big projects running there near our breweries in Spain that are also water stress. It's not. It's also in Europe where we face water stress. Now, what is water circularity? So, for example, I think the most simple example is that you treat your wastewater up to drinking water quality and bring it back into the brewery. We do that for the non-essential parts of our production process. We do that specifically having these water reclamation plants in for breweries that are in water stressed areas, like in Mexico. You see the one on the above is one of our most recent breweries in Miyoki in Mexico, but we also do it in Indonesia. It takes some investment to do that. So you need to have a good business case to set up a water reclamation plan. But there are interesting opportunities outside as well. So maximizing circularity is, for instance, that you do aquifer recharge or constructed wetlands. You could reuse your treated wastewater if you treat it in the right way for agriculture. So farmers nearby could use it, including putting water in an irrigation canal that is used by a farmer. You could also send it to a next industry user. For instance, if you are having a paper industry nearby, they could reuse your treated wastewater. They don't need excellent quality drinking water. Now, all these elements should be measurable, so it should lower the pressure on the water table. And then, of course, and that is also what Mark van Loosrecht was referring to, it's also about recovery of resources. You can actually take out quite some of the resources from wastewater. So one of the things is that we transform wastewater into biogas, and we reuse the biogas for for the heating process in our boilers. We do that in many breweries around the world. But for instance, and even in COVID times, sorry. Yeah.
No, it's just we have an ambitious timetable, so I'd like to ask you to come to a conclusion for this part, and then we have a short discussion with Dimitris later on.
Absolutely. So just to give you an example, also in COVID times, where we needed to bring back unused beer to our breweries, we also transformed that into biogas. And another use is transforming a wastewater sludge into organic fertilizer. So these are some examples, and then we can come back on potential obstacles and how we solve them. Yeah. Thanks,
Jan Willem. I see some nice questions coming into the chat as well for you. Maybe you can have a look at it as well, because we cannot cover them all. But thanks for those questions. I'd like to go to Dimitris Xavienos from Zero Brine. Dimitris, you're with us. I've seen you just a few moments ago.
Yeah,
there's a few. Hi, Dimitris.
I'm with you. I hope you can hear me. Okay.
Yes.
Thank you very much.
Good to have you with us. On a first note, what is you've prepared some slides as well. My first question would be, what is Zero Brine exactly? Because we all know what Heineken is or does, obviously, but Zero Brine, please tell us about it.
Yes, definitely. Maybe so let's start with the fact that Zero Brine is a Horizon 2020 project. And just to things about Horizon 2020, maybe, of course, the audience is familiar with that, but it is the 8th framework program from the European Commission. And it started from 2014 and it ended in 2020. And within those 7 years, there were in total 84 water-related projects. So Zero Brine is one of those 84 water-related projects. From the start of the Horizon 20 towards the end, the European Commission was funding more and more circular economy water-related projects. In total, they invested 554, I'm taking a look at my notes, millions. And Zero Brine is one of these 84 projects with 10 million of a budget. The title of our project now is about the value chain, as Mark Wallostek also noted a lot, that we have to look into the value chains, redesigning the value and supply chain of water and minerals, a circular economy approach for the recovery of resources from brines, from the salty wastewater generated by process industries. The project started in 2017 and it's about to end, as you can see this month. We are 21 partners and it's being coordinated by TU Delft. Our coordinator is Professor Luc Rietveld from Civil Engineering faculty, and I am the innovation manager of the project. Now, since it talks about large-scale demonstrations, it is an innovation action, meaning that we want to have large-scale demonstration in actual industrial sites so that we are close to the market. We have 4 of those, one in the Netherlands, in the Rotterdam port, where we have the industrial cluster and the main utility supplier of the mineralized water, everyday industry water. Then we have one large-scale demonstration in Poland for a coal mine industry, one in textile in Turkey, and one in Spain, which I'm going to focus on today, which is a chemical industry. It's a precipitated silica case where they were facing a lot of difficulties, as I have in my next slide. I don't know if you have any other question about the project, or we can maybe describe a bit more the case of the precipitated silica. Okay.
Yes.
Right. So it is not a surprise that most of those type of innovations are regulatory driven. So our end user there in Zaragoza in Spain, IQE, had a problem with the wastewater and with the local regulator, because they are anticipating a drastic increase in their market sales volume because of the phasing out of black carbon. So there is a rise of green tires, and precipitated silica is the main competitor to the black carbon. And now they see a drastic increase in the product, but they cannot really grow. So there is a limitation to their business growth because of regulations. The problem is that they are discharging a wastewater of around 20 grams per liter, mostly with sodium and sulfate inside. And the local regulators tells them, forget it, you're not going to get an expansion to that. So to this limit, I mean. So then the idea is that they need zero liquid discharge. And then the circular economy opportunity arises. Now, what I'm trying to say with this slide, I have a lot of details, but I want you to keep one thing. the circular economy value that you see in the middle. The business opportunity per ton of product, if you go through the analysis, is around 275 euro per ton. So we have seen what is the production cost in detail with the end user. They have shared the data, what is the selling price, and if we allow them to have more tons sold, they can get 275 euro per ton on top. Apart from that, though, we have now developed suitable technologies to treat the wastewater and recover resources. So the sodium sulfate that we can recover, and one of the technologies, the key technologies there is eutectic freeze crystallization, which has been invented, by the way, by TU Delft, is an important technology. So technology can enable that, but there are a lot of other aspects that need to be taken into account. If you take those two components now, the new business opportunity and the circular value coming out of this wastewater from the salts recovered, you can see a total of 465 euro per ton to really finance the circular economy implementation. And at the end of the day, this will be totally in line with the new policy that is being promoted by the European Commission about zero pollution, the Zero Pollution Action Plan. Now you can see on the right hand below, SSBD stands for Safe and Sustainable by Design Chemical Products. All these are really now putting in the agenda at the European level, but also globally. Okay. Yeah, that in a nutshell for my second slide.
Yes, thanks a lot, Dimitris. I think we'd like to leave it at this. I'd like to ask you and both Jan Willem and also maybe Mark to really take a close look at the questions in the chat, because there's quite a few coming by. We don't have the time now to cover them in our discussion, but at the end, from a little bit before 4 o'clock Central European time onwards, we will take a look at what has been Willemien, first of all. Hi, there you are.
Yeah, thank you. Hello, everybody. Hello, Bart.
Hi. First of all, as a first question, what's the role of water in a future-proof agriculture? It's quite a big question, but to give you some opportunity to give you some context to this discussion.
Yeah, thank you so much. Well, indeed, it is a big question. As the audience might know, for the Netherlands, these are very much integrated for centuries already in the way we work and live in the Netherlands. Water is an essential part of our living as we are the Delta. But I believe in general, water is going to be a more important topic in future, as it is already now because of climate change. And I think we even need to look more and more to ways of using water efficiency for our agricultural production, and look at the climate impact and also look at new growing systems. As you know, in the Netherlands, we do not only produce outdoors, but also indoors, and more new growing systems are developed that are especially focused on efficient use of water for production. But I think we also need to look at other questions. For example, how do we grow on more saline water, brackish water? How do we reuse and clean our waters, like some of the examples that were mentioned by the previous speakers? And also, how can we use components from the wastewater into, for example, packaging, nutrients, and fertilizers for agriculture? And I think this integrated approach is crucial.
Okay, thanks. There's a role what the Netherlands sees for itself, and I think we already take that role, is that we have a mission-driven policy. Can you? There's the cooperation between government, knowledge institutions, business. Can you tell a bit more about how we go about in foreign countries?
Yeah, thank you for the question. The mission-driven approach is, you could say, much alike with the European mission-driven approach that is now developed on the Horizon Europe. In the Netherlands, we have a top sector and mission-driven innovation policy, and missions are more or less the aims for the futures for the Netherlands. And in agriculture, we have like 5 missions for food, water and agriculture. And here you see already the linkage between water, food and agriculture. For example, circular agriculture, this is the reuse part. How do we reuse the water in an efficient way? The climate neutral and climate resilience is about too much water, climate resilient cities, but also water quality. Well, sustainable waters and delta are obvious, I guess, but also in good food. I think safe foods, the safety of our waters are crucial as well. So mission driven is the mission we want to aim for at the future. And indeed, in the Netherlands, we believe strongly in a public-private approach, which means that in all the things that we do with regards to innovation, we try to challenge companies, researchers, the farmers, the consumers, together to come up with new innovations to answer towards a more circular agriculture or towards a more climate smart agriculture. And we do not only do that in projects, we also include education. And as you can see, more and more there is an aim or vision towards what can key technologies do in that respect.
Thanks, and I think some of that maybe I don't know if the way we used to do it is work out if it works in the Netherlands and then try to implement it abroad. But we also have direct projects in other countries, right? You have some examples of those. Could you highlight a few?
Yeah, that, of course. I think thank you for the linkage. What you're saying is right. As top sectors, as Netherlands, we of course fund a lot of projects or programs in the Netherlands to support this ambition, and indeed we cooperate on this as well with other countries within Europe. That is really crucial for us, related to all kinds of farm to fork and water policies of Europe, but also more abroad. So maybe the next slide. I have 3 examples, depending on the time. Totally different ones, but I'm going to look at it from a perspective of the reuse topic. Mekong Delta is in Vietnam, and the Vietnamese government is working on an agriculture transition plan. And as the Netherlands, we are as also a Delta, we see opportunity to cooperate on this as well. And on this sheet, you see a lot of topics. Brackish water was mentioned already, agro parks, rice production, which costs a lot of water. But we want to aim for a multi-annual cooperation with Vietnam on the Mekong Delta in an integrated way. And for example, we just launched a small challenge with the embassy of the Netherlands in Vietnam to challenge parties to come up with a reuse and a recycle and recovery projects in the Mekong Delta. So this is very, very concrete at the moment. And also, for example, on the animal husbandry, most of the people think of plants, but also the animal production is using a lot of energy and water. And also in that respect, we are looking at reuse of water as well.
Okay, thanks. And there's 2 minutes more if you want for some additional examples.
Please go to the next slide. I want to stress that also internationally, we try to do the same approach as we do in the Netherlands, so public-privately. So for example, in Mexico has a lot of horticulture development areas at this moment, but they are dealing with a lot of challenges when it comes to the drain water from the greenhouses. So in the last 3 years, we set up a project with Mexico, with the government, with the horticulture companies to clean the water from the horti areas and to reuse it for the horti by using algae. And this algae can be used again as feed for the chickens. So this is, I think, a great example of a circular approach where not only the water is cleaned and reused by the industry, but the algae that can clean the water can be used for other purposes as well.
Okay, if you want, maybe let's tackle one question instead of one of the projects. Is that okay with you?
Yeah.
What are the main techniques to manage the backwash stream from ultrafiltration processes? Sorry for the failure, including the stream from the CEB and CIP cleanings. You can see it in the chat as well. It's a question by Everton for you.
Oh, that's a very technical question. If it's okay, I come back to the question on the chat because
In the
it's
chat,
a bit
yeah,
too
that's
much
okay.
detail.
That's okay.
Yeah.
Yes. Yeah, sorry.
No, that's okay.
Yeah, I'd like to leave it at this for the moment, Willemien. Thanks very much for highlighting the mission-driven policy and the international projects you're working on. Thanks a lot.
You're welcome.
Going towards the third part, safe resource recovery and the European Union perspective. For that first part, I'd like to invite Nienke Hofstra on the online stage. She is associate professor at the Wageningen University, the main agriculture university in the Netherlands. And she will talk about how wastewater reuse can be a serious health risk. Hi, Nienke.
Hello, I'm here. Cannot switch on my camera, so I hope somebody else can do that for me. Okay, there we go.
Yes, there you are. Hi.
Thank you. So yeah,
Yes, shortly introduced you, but I'm really curious to know what are the main health risks if we want to reuse water.
Yeah, I think health risks are indeed important to take into account when we look at all of the processes that people have been discussing already. And if we go to my slide, then you can see that I put there as main contaminants, the pathogens and the chemicals. And I also think that antimicrobial resistant bacteria and genes are important to think about when you talk about health risks. And users of the water, but also of the produce produced from the wastewater, can provide health risks to the people. And these health risks really depend on the use and exposure, but also the sources of the water. So, for example, when we talk about the water use, if the water needs to be cleaned completely to be used as potable drinking water, then the cleaning parts are of course different, but also the health risk will be different than when wastewater is used in agriculture. And also when it's used in agriculture, for example, there are differences for which produce the water is used. So if it's used for vegetables, the health risk will be different than when the wastewater is used for wheat or corn or other products. And also when it's used from industry, of course, there are differences in health risks. Yeah. Then they also depend on the source. And for example, if the source is indirect, when surface water is used that is polluted, then the health risks are different than when wastewater treatment plant effluent or sludge is used, etc. And there are many other opportunities to use wastewater, of course. So it's important to think about reuse as that it can be formal and informal, and also that will influence the health risk, because when it's a formal use, I think people will have thought about the health risks. But when it's informal, that is not always happening. And it's important to realize that wastewater reuse is actually a common practice around the world, used in many cases informally. And wastewater treatment is still very limited around the world. You will always see this number of 20% that is only treated. And I'm not completely sure where that number comes from, but this shows that the health risks are large. And that this really contributes to the diarrhea disease burden. And that has been very large over the past years. Also, when you compare it to COVID-19, for example.
So would you say there's a really lack of awareness on this issue worldwide?
Yes. Well, among many people in the world, I think there is a lack of awareness. Yeah.
Yeah. Yeah. Okay. And what could be successful solutions to tackle this?
Well, interventions, if we move to the next slide, interventions that can be important to prevent health risk include adding barriers. And these barriers, again, really depend on the use and the source. Of course, it's not the idea to treat the water unlimited. So you don't want to create a potable source where it's not necessary, right? That's important to take into account. But it really depends on the use and the source, again, of where the barriers need to be placed and how they need to be incorporated. And I think you can make those decisions on the barriers by thinking about safety plans. And an example of these plans are sanitation safety plans, where reuse is actually also included. And in these safety plans that are the sanitation safety plans that are proposed by the World Health Organization, they really help to identify what barriers are required. So these safety plans look at the sanitation system in this case, and for reuse it would be the reuse system. They look at the health risks that are related to the exposure to the water or to the produce, and then plans are developed to to improve the situation, and they have focused in within the WHO on the incremental improvement plans, because while technology is available, I think, throughout the world, implementation is not always possible in many parts of the world. So the Heineken, of course, is able to do these things, and there are other organizations through which it's very well possible. But in many parts of the world, it's not possible because it's too costly. There is not enough knowledge on building barriers or maybe on maintaining them. But also there is a lack of awareness, as you mentioned earlier.
Yeah. Thanks a lot for now. As I said, I just saw a question, but okay, no, let's leave it at that for the moment. Nienke, thanks for your concise presentation on these health risks and the way to address them. Thanks a lot for now. I'd like to go to the European Union perspectives. Hans Tielstra. He joined us last month at our first webinar on clean water and ecosystem restorations, introducing the EU perspective there, and we asked him to do the same thing today. Hans, welcome again this afternoon. Good to have you back. As a short introduction, you mentioned last time that less than half of the targets of the Water Framework Directive from EU member states have been fulfilled as of now, and that means a lot of work still needs to be done together by member states. So policy areas like agriculture, energy also need to emphasize the central role of water in their systems. That was an interesting remark. Taking it one step further, you work on the Urban Wastewater Directive that will be launched in 2020. And that's really a process that's running at the moment. You're looking for what sort of inputs to make sure that wastewater directive is as good as possible.
Sorry, I didn't catch your last question.
No. What sort of dialogue or what sort of input are you looking for that urban wastewater directive? Because it will be launched next year, and as I understand, the process is running now to make sure you get all the input you need to make the directive.
Yeah, correct. Well, indeed, this consultation, this open public consultation, as we call it, has been launched. It was, I think, 2 days ago. But the kind of input that we're looking for is really on a very wide range of topics. I mean, the wastewater directive, as it was initially conceived, was all about protecting public health and protecting the environment. But of course, as we have heard from previous presentations, I think the whole angle on wastewater has changed, and we want to use in the future that directive also for a number of other purposes. So this open public consultation, which you will find on the Have Your Say website of the European Commission, launched 2 days ago. So it's really on all those topics, whether it's about pricing or the reuse of certain resources in wastewater, the energy component, etc., etc. So there's a really broad spectrum of issues that we are looking to get input on.
And that broad spectrum also reflects the current transition that we're in. So, as I understand, it used to be called different. I don't know what the old name was, but that different purposes and that broad perspective you take is also a reflection of the transition we're in, of a broader use of wastewater.
Yeah, you know, it's something that hasn't been decided. This is at the moment an idea that some people in the business have thrown up as a possibility. At the moment, it's called an Urban Wastewater Treatment Directive. which, as I said before, really puts this angle on health and environment. But we think that we have to have a different angle, or maybe an additional angle on urban wastewater, which is as a source of resources, as a source of energy, as a contribution to climate mitigation. So yeah, this is one idea that we have, that perhaps if we are changing perspective or adding a perspective to this piece of legislation, we might want to also change the name of this directive. But let's see, that's something we will come up with in the course of next year.
Thanks. Talking at another directive, the Reuse Regulation Directive, that will start from now on. And I'm wondering what sort of impact you think that will have for the industry.
Well, the reuse regulation as we have it at the moment, and the rules, by the way, only kick in 2023, is quite limited for now. I mean, it's limited to the reuse of water from urban wastewater treatment plants for irrigation in agriculture. So that's relatively narrow in terms of scope, yet we think there is a huge potential within the EU to increase the use of wastewater for that particular purpose. Our estimate is that there's potential for a 6-fold increase of that type of water as an alternative source for irrigation. But beyond agriculture, which is evidently one of the biggest consumers, certainly in the summer, of water, and certainly in the southern part of Europe, there's of course also other possible uses for this technology. I mean, we are looking at ways of increasing its use also in industry. We hope that we're also evaluating our legislation on industrial emissions, and we think that legislation could also be a way to stimulate the reuse of water. Overall, the challenge we have, of course, is that from the EU perspective, we need to legislate for 27 countries, which are very different in terms of their geographical situation, but also their economic situation and their social situation. So we need to find a tool, a legislative tool that works for all those countries. So that's not going to be so easy always, but that's what we try to do. So agriculture, industry, and the recharge of aquifers is another area that we think at some point we have to develop some sort of initiative on to promote that more.
Thanks for now. I was just wondering, you did prepare 1 or 2 slides, did you? Or
yeah. I prepared this slide, but maybe now that we have moved on a little bit in discussion, let me just highlight what's there on the right-hand side of this slide. We're revising this legislation, and now in this case we've been talking about water reuse, and we've been talking about the Urban Wastewater Treatment Directive. The challenge that we have, of course, is that we have to deal with a number of existing problems. You mentioned that less than half of the water bodies in Europe is not yet in a good status, and that's true, and we need to use the next couple of years to try and address that in a very serious way. But at the same time, we need to prepare ourselves for future challenges. And on the right-hand side of the slide is one that I find quite telling here. You see here a number of European countries, and you see that over the years, the amount of water is still on this slide, that the amount of water available per citizen is decreasing. And this is simply over the course of the past 20 years, or not even 20 years. And you see quite significant decreases. So that's a type of problem that we need to take into account in the development of future policy.
Yeah.
And this is just one of them. There's also the other ones that the previous speaker mentioned about chemicals in water or pathogens in water or antimicrobial resistance, etc. So there's a bunch of issues that needs to be considered.
Yeah, thanks. Let's leave it at that for the moment if you want, because then we go into the discussion with basically almost all our panelists. So thanks to all presentations so far. I'd like to invite Mark, Jan-Willem, Dimitris, Willemien, and you, Hans, to our final discussion, talking about how do we realize systematic change. We've touched upon that topic from various angles, but maybe see if we can come to a nice wrap up. We'd like to look at it from a finance, a governance, and a legislation perspective. First of all, I'd like to give the floor to Mark van Loosdrecht, Technical University of Delft. Reflecting on the discussion so far, what are the most striking points you have heard till now? Mark, you were with us. I've seen you answering questions in the chat. So, yes, there you are.
I'm there. Yeah, it's of course a wide variation of topics and difficult to nail that down in one or two things. And in this respect, I just want to reference that there is a need for really look to this kind of things on a systems level, and that's making that's on one hand very obvious, at the same time very complex because of the many players in it. But if we want to make an optimal system, we need to do the things at the right place and also accommodate that it's possible, and that's not that a company like Heineken should solve all the water problems in the region because they grow barley there and they produce beer there. Heineken is part of a solution, and that's the same for a municipal treatment plant, and that's the same for the local water farmer organization. So somehow we have to find a good way to organize this without falling into the trap that everybody is defending their own position.
Yeah. What do you feel of the role of local governments? Because we've heard Willemien from the Dutch government perspective. There's the private sector acting in different countries. Yeah,
water is by definition a local problem. If you try to solve this globally, you end up with non-workable solutions. You have to do this locally because even in the Netherlands, the water situation on the Veluwe is very different than the one in Gouda. So if you do not involve the local conditions and think you can set, for instance, from EU point, would set very general rules for all of Europe, that's not possible. You can give directions in the way where to move, but you will have to look to the local conditions, what's possible, certainly for water, for energy, and for resources which you recover. That's, of course, certainly the resources of the global market. So there, more global approaches will be needed in order to develop, for instance, a phosphate market which can accommodate recovered phosphate from wastewater treatment plants.
Yeah. When we had in a short online pre-meeting earlier this week, you introduced the perspective of who owns the water. That's maybe a final question for now, and then I'd like to give the floor to our panelists. But could you reflect on that question a little bit more? Why is it crucial to this topic of today? Mark, can you reflect on that question? Who owns the water? You introduced that topic.
Yes. This was partly also. So if you have a water shortage, but if you in the end make something where there's demand for, then you get the problem who owns what. And I use here Camera very often, or maybe even the cellulose from the toilet paper. If someone can make a product out of the cellulose which is recovered out of a wastewater treatment plant for value, then who's then owner of that originally? Because you dump it for free in the toilet and then someone makes in the end profits with that. How do you balance these costs? And that's the same for Camera, as the one who receives the fecal matter and produces then Camera out of it. How do you deal with that? Then in the end, fecal matter becomes something like, say, metals which are collected in the city. And that kind of value chain is there. And that's the same for the water. If Heineken uses river water and uses it, treats it, and then may use it for something else, is that water become completely property of Heineken, or is Heineken only leasing it for the time it's in the factory? and then gives it back to the society. This kind of issues, they are discussed, but there's no general consensus how we should look up into that in a fair and efficient way.
Yeah, Willem, could you reflect on that from a Heineken perspective?
On who owns the water? Yeah, I'm quite simple in that. Of course, we don't use or we don't own the water. Water is a typical shared resource. So we need to work together to use it as and treat it with as much respect as possible, especially in a world where the pressure on water use is growing and growing, not only directly through what we consume, but most of it indirectly in everything we wear and eat, etc. So no, absolutely a shared resource, and that's also why we need to have shared solutions.
Yeah, thanks. I'm just going through to the different panelists, and Dimitris, I recall that last Wednesday you also introduced the topic of systematic change and the barriers to scale things up. You have been involved in various pilot projects. You said in the Zero Brine project, the 4 of which you talked a bit more about the Spain topic. Can you reflect on some of these obstacles to achieve systematic change and to really scale things up?
Certainly, Bart. Thank you very much. So we're discussing about reuse, recycle, and recovery of resources. So in principle, what we're discussing about is a transition from a linear to circular economy. And as every transition, you need to go from one socio-technical system to another one. This is not about a technological change alone. It is about a system-wide transformation. And as such, you need to think about systemic innovation. You have technology, of course, that is super important. You need innovation to drive that, but in the technological terms. But apart from that, you need to have a look at regulatory innovation, at circular economy business model innovation, at skills, at social innovation. All these are very important, because if you have only technology and you can even get the best product out of that, very, very pure. End of waste is a problem there maybe for that. How can you really get this material back to the economy if you cannot decharacterize that? So whoever designs such a circular economy solution needs to take all this into account and really co-design also with the relevant stakeholders throughout the supply chain and the new socio-technical systems. That is a quick feedback that I could give in that respect, Bart.
Thanks a lot. Going to a question by Hamed Rastegarian. Thanks. Do you think increasing the virgin raw material taxing could be an option? This can introduce new value in supply chain for recovered resources and might ease the change in regulations. Just an idea, he is humbly stating. Who can I give the floor to reflect on that question by Hamed? Maybe Hans, is that from a EU perspective, that taxing issue, is that something you can reflect on?
I think you're asking the wrong person. I think if there's one thing that is contentious at European level, it's introducing taxes.
Yes,
but,
of course.
you know, if there's one element that has been very difficult for us to get a grip on, it is precisely the price of water in our case. I mean, in the case of the Water Framework Directive that we are responsible for. I mean, I think everyone understands the logic of putting a price tag on a resource as a way to make the system run more efficiently and more respectful of the true environmental and resource costs. But it's proven to be difficult, at least on the basis of the Water Framework Directive of the European Union, because it has a fairly fuzzy description.
Yeah, thanks. Mark, you're not a tax authority, but you do have insights in how business cases work. So would you say this taxing idea could work?
Yeah, I already typed an answer. I think that's, as an engineer, I would say as engineers, we have to work on just try to make products which have added value so that the system drives itself. There's nobody, all the gold, silver, iron, copper, they're all very efficiently recovered in society without any regulation, because there's value in the recovered material. So it would be much better if it's driven by the value of the recovered material rather than by taxation, because taxation will in the end prevent also recovery. One of the problems we face is that this is not taxation, this is then subsidy, but it's also government interference. There's subsidy on biogas. This means that organic material, if you want to produce now chemicals out of it, becomes less available, because the price of the organic waste is set by the subsidy on the biogas. And that limits the further development of new, maybe more efficient ways of reducing the organic carbon in this kind of system. So very often, if you do taxation or subsidy, initially it's a good system, but in a few years it often starts to hamper new development. So it has to be done in a very smart way. And from an engineering perspective, I think as an engineer, you should try to just look to the value added part rather than the legislation part.
But still, subsidies can help in the first 1, 2, 3, 4 years, and then they should be abolished. Yeah.
Maybe Bart, I can add a bit on that.
Yeah, please do, Wilhelmine. Yes. Yeah.
But because I'm totally not an expert on taxes, I know a bit of the bio-based industries from Europe. I think in general, a level playing field, or attention for level playing fields and innovation, is important and key. If you talk about recovering from water resources, but reuse of resources in general, I think, I don't know, Dimitri called it, but it's a transition. So it takes time. It's not there from the one moment to the other. If you develop something, you need scale, you need demonstration. And actually, this is what I really like about the bio-based approach of Europe, that this stepwise approach is taking into account, together with industry, to develop, to not only innovate, but to create and to scale along the line.
Another question I would have is there's plenty of things being said about tailor-made approaches. There's also sort of general things you can do. Maybe for Jan Willem, from a Heineken perspective, you have all these breweries around the world. Are these solutions you're looking for in water recovery and being efficient? Is it always a really tailor-made challenge, or are there some lessons you can learn from other breweries and things that work in a general way in all countries?
Yeah, it's a good question, because Mark rightly said that water is a very local issue. So you cannot solve it globally, but you can learn from each other and also share best practices. So just to give you a very simple example, we use or transform wastewater sludge into organic fertilizer that is being used by farmers, but it is not always readily accepted. For instance, in Ethiopia, we started to do that. However, sludge can also have a bad reputation, as it is often associated with human waste. And in Ethiopia, having faced challenges disposing of waste sludge, a brewery in Harar, which is a city in Ethiopia, partnered with the local hospital to challenge those misconceptions. And they compared crops grown without fertilizer, using chemical fertilizer, and using our own sludge as fertilizer, and the results were positive. So the approach is now being expanded to other breweries as well. And also agricultural teams are being trained in communities across Ethiopia. So there's a lot of best practices, yeah.
Thanks. Sorry to look at my smartphone all the time, but Nupur is transferring these interesting questions. This is one by Professor Huub Reinhardt. Does the urban wastewater directives, this is a question for Hans, also going to include circularity aspects, for instance, reuse of water of effluents by wastewater treatment plants, by nearby industry, agriculture, etc.?
Well, I cannot be very specific yet about what it will include and what it will not include, but circularity is certainly one of the big considerations for the review. I mentioned also energy consumption, energy production possibly, There's many different aspects to look at, also some more bureaucratic ones, if you like, to do with reporting and monitoring and such. The quality of the output. But circularity certainly is one of the considerations. And at the same time as revising this urban wastewater treatment directive, we're also revising the sewage sludge directive that we have in the EU. So that regulates what to do with sludge, where to apply it, and where not to apply it, the components, the health components, the health-related components of it, etc., etc. So that package taken together will certainly look at circularity.
Thanks. There's a few more minutes for this discussion. I have a question for Dimitris by Jenny. The Aero Sea Basin area pollution. Water is used intensively for rice and cotton. Water is used mostly one time without reuse. How brine and brackish pollution water could be reused in such a region?
Yeah, I saw that question. I would like to receive more information about the compounds inside the wastewater, so that I can be really meaningful in my reply. So this is why I'm giving to the chat in the chat box my email address for people to follow up. In general, we are dealing in the project, just to mention that, with brines, which has to do with salts and inorganic compounds within zero brine. So if this project or this specific case has to do with such type of pollution, please do get in contact with me through my email. You can find that in the chat box.
Okay, thanks a lot. Quick check with Nupur. Are there specific questions you'd like to highlight? Because there's plenty of stuff coming by. I saw a question by Erik Roesink as well that struck me because he was in our last webinar. It's a question for Heineken. Is from the sewer to the brewer a realistic option, Jan Willem? Or will Heineken brew beer with treated wastewater?
Yeah, I assume from the sewer to the brewer, it is the question is, are we using treated wastewater directly in our brewing process? Is that correct? Mm-hmm. Yeah,
I think so. That is what I have on my my DAC. Yeah.
So technically, it is possible, but physically we don't do that. So when we treat wastewater up to drinking water quality through our effluent reclamation plants, we use it for the non-essential parts of our production process. So for instance, for cleaning, etc., but not for the core process. It is technically possible. Reputation-wise, it's still quite vulnerable. So for now, we don't do that. Yeah.
Understandably. You also said there was some religious angles to this discussion, right? When reusing water. Can you reflect on those?
Yeah, you can imagine that we are operating in 70 countries around the world, and some of them are religious or Muslim countries. And if you want to reuse treated wastewater by other users, and it is coming from an alcohol-producing company, you can imagine that users don't want that reused treated wastewater. So that could be a religious obstacle, yeah.
Yeah, understandably. There's one more question. What kind of substrate preparation is needed to put food waste into recovery stream, from bringing kitchen waste to treatment plants? It's a question by Terani D. It's a question for Mark.
Yes, well, there's always a bit of question. In principle, if you want to recover materials, the organic waste in the city is mainly the kitchen waste and not that much the organic material in wastewater. So for producing in the end bioplastics or chimera or recovering of nutrients, that organic waste might be a much bigger source. Now, I don't think it's a good idea to just chop up that and try to transport it through the sewer, because you get all kind of anaerobic process in the sewer leading to methane emissions, etc. It's much more efficient, like is done in the Netherlands, collected at the homes and bring it to centralized facilities where it could be processed either into biogas, but also nutrients potentially can be recovered. And certainly if we manage to make chemicals from waste working to produce their new chemicals out of the waste, either the ones we showed, but there's several other chemicals which you can produce. And again, it's not they're not that much technology, or there's a lot of development. It's in the end this value chain development which is limiting here.
Okay, thanks a lot. On a really super final note, I'd like to give the floor to Dimitris for a very short answer. What is the most applicable zero brine technology developed in the project? If you think about efficiency, costs, and sustainability impact.
Yeah, I think that is a question from Arjen from Vitaven Boss. I replied also in the chat box.
Okay.
My impression or my belief is that there is no single technology that can really get this target. You have to combine different technologies. That is what we are doing within Zero Brine project. We combine from membranes, different concentration crystallization technologies. There is not single one technology that can really recover the resources. From the Zero Brine project, what I told also in the chat box is that there are very innovative technologies that are now close to the market. And I mentioned two. One of them again is the eutectic freeze crystallization technology that we have been developing at TU Delft, and that is just an example. But please get to see the project results more closely from the website and from my email address.
Thanks a lot, Dimitris, for this final answer. I'd like to close the webinar by thanking all attendees for being with us in this webinar, and a special thanks, of course, to our panelists. Thanks a lot for sharing your insights, expertise, and knowledge. Taking a look at the agenda, our next webinar will take place on May 28th. Risk and resilience, and number 4 is community engagement and intersectoral collaboration, end of June, 25th of June. And that all leads to the Amsterdam International Water Week, beginning of November, 1 till 5 November. So thanks a lot once more, and hope to see you back end of May 28th on risk and resilience. Thanks a lot.
Thank you very much.
Bye-bye.
Bye-bye.
Cheers, bye-bye.
Thanks for moderating, Bart.
Thanks, Jonathan, bye-bye. Cheers.
Bye.